St. Nicholas.
Thanks. Hi, everybody. Should perhaps wait until the end because, well, it seems on the program the talk has been like taken the first sentence. It should be chopping the monolith. So perhaps there are not that many people because, yeah, the first sentence doesn't look that cool. Anyway, I'm Nicolas Frankel. I've been a developer for 17 years, working on different projects, consulting in different positions, developers, team leads, architects, solution architects, but then I became dissatisfied with the state of our industry. Mostly I was to solve organizational issues with technical solution, and it's a waste of time. It doesn't work that well. So now I'm a developer advocate. So if you don't listen to what I'm telling you, that's fine. I won't feel frustrated. It's just advice. You do whatever you want. Good. That being said, I think in Poland it shouldn't be a problem, but in some countries it might. There is a lot of controversy inside this talk. It might hurt your feelings. So if you don't feel comfortable having your world put upside down, please leave right now. Afterwards, I'm not responsible. Again, in Poland, I'm not sure it's an issue, but in some countries there is this like disclaimer. Right now, everybody cheers about microservices. Who is doing microservices here? Yeah, be proud, you are doing microservices. No, it's keep your hands up. Keep your hands up, I want to see everybody. Yeah, you are doing microservices. Good. And you are good developers for that. And if I'm not doing microservices, I'm a bad developer. That's, yeah. You also are a bad developer? Yeah. So we are bad developers. You are half good, half bad. So, yeah, not neutral, it doesn't work. So you can say the Joker card, hey, I'm doing microservices because, hey, microservices are cool, or microservices are not good. Hey, I'm doing monolith. So still, especially at conferences, people are saying, hey, microservices rock the world, you should do microservices. If you don't do microservices, you are one bad developer because the future is there. And, well, that's the first controversy I want to fight. It's, I believe, a lot of talks, and it has been completely like changed. At the beginning, it was quite different. So, well, first, let's go back to the definition of microservices. Like Martin Fowler wrote it for me. I won't like pen myself by reading it out loud because I've been learning that you shouldn't read out your slide. You read it, you know what it is, blah, blah, blah. Now, most interestingly, there are some characteristics, and now I need to find the right place to put, yes, it's here. And the characteristics are very interesting because in general, the further down you go, the harder it is, like componentization. It's the basics of microservices. So if you say you are doing microservices, you are doing componentization, that's clear. Now, if we go to the last bullet point, again, that's not my definition, it's the definition of Martin Fowler. If you're not happy, you tell him, yeah, I'm sorry, it's a bit low, but it reads products, not projects. Who here is doing microservices with projects and not products? So first, let's define what's the difference. In a product, you don't have an end date. And in general, you have a recurring budget. A project has an end date, and you got the budget from the beginning to the end. Well, in general, because you always ask for more money, but that's a different thing. So who here is doing microservices with project and not products? Come on, yeah. Okay. I guess the other are a bit too afraid, but that's fine. Thanks for your courage. So now you can say, you cannot say you do microservices anymore. I'm sorry. Martin Fowler said so. Sorry. Again, complain to Martin. I'm not responsible. I mentioned at the beginning when we started to hear about microservices, people were like very, very careful. They were always telling about Conway's law. Basically, Conway's law is if you want a certain architecture, you need your organization to mimic the architecture that you want. This is Conway's. The guy around, I don't know, but this is Conway. Nobody talks about that anymore. Now everything is about technical requirements, what you need, compensating transaction and stuff like that. So those same people, they say we need to reverse Conway's law. If we want a microservices architecture, we need to be organized around teams. But now our architecture is layered because we are organized around like layers. You have the front end, you have the back end, you have the DBAs. And of course, your architecture mimics the organization structure. So we need to evolve from this organization to this organization. Again, question for you. Who among you who are doing microservices is organized like this? That's not too bad. More and more each year. That's pretty, like let's say, 20%. And there is a company, a big company, who is organized like this. And actually, they are promoting it, like AWS. And they say, hey, 2 pizzas team. Because remember, the team must be self-organized, self-sufficient, so it should be fed by 2 pizza. Again, depending on the country, it might depend on the number of people. The size of pizza, how much you eat, whatever. But it's a rule of thumb. It shouldn't be too big. It shouldn't be too small. And so you already answered. Whose organization is like this? 20%. Every year, I see more and more people organized like this. However, my experience is that it doesn't work like this. In general, there is an architect, somebody who has political power. Oh, I see smiles. Feels like at home, right? Somebody reads a technical article about microservices, that if you do microservices, all your problems will be solved magically. And it's the case. Like everybody knows that if you do microservices, all your problems will be solved. So this very smart person, but technical person, reads about it. He remembers only the benefits and a couple of technical requirements because, well, he's a technical person. And he only applies the technical aspects. And guess what? Now he can write microservices on their resume and leave for the next failure. And who is going to fix the mess? I don't know. Oh, hello. So why are we talking so much about microservices? We are not stupid idiots in general. We are trying to achieve something. So if we check what we are trying to achieve, we might see the reason why we try microservices and perhaps forget about microservices, but check alternatives. So again, Martin Fowler, I'm super lazy, lists several benefits. He lists strong module boundaries, independent deployment, and technology diversity. So let's see each of them to see if it's a good idea. Strong module boundaries. Of course, if you deploy independent units of work, they will be completely independent of each other. They will have strong boundaries by definition. However, it's like saying, oh, I will try to walk a bit more, so I will sell my car. If you don't have a car, you will need to walk. But perhaps there are better ways to walk a bit more without selling your car, because then what are you going to do when you need to move big, heavy stuff? So for example, in the Java world, there is modules. Okay, nobody uses them, but still, they are modules. So you can say, let's use modules. You can have rules in your Sonar configuration to say, hey, this module shouldn't depend on this module. Sorry, this package shouldn't depend on this package. There are many, many ways to achieve independence without going the microservices way. So this is not the right reason. Technology diversity. Who here loves Java? Hey, we are at a Java conference, folks. And just a reminder. Okay, not that many. Kotlin. Kotlin for the win. Rust. Okay, let's try Clojure. No, okay. JavaScript. It seems there are more hands for JavaScript than for Java. Folks, you should really be careful. TypeScript, then. Yeah, TypeScript, yeah. Everybody has their favorite language. So technology device diversity should be an asset. Like you are in a team of Java developer, but you want to do Kotlin, you come, you put your libraries, you write your stuff, and apply. It works. It's really good to be diverse, right? Yeah, no, you don't think so? Who is going to maintain the mess afterwards, after the person who loved Kotlin, Haskell, JavaScript, whatever left? Who? Again, the same person who will have to fix the mess by the architect who read about microservices and left. Probably it will be you, or not them. So this technology diversity is just, in my opinion, very developer focused. We can argue about the benefits of technology diversity regarding databases. Yes, databases, some of them are very, very focused on something, other on something else. They are so diverse that, yes, we need them. But languages, that's not true at all. So while we love to have our own pet languages at our work, it's not for the benefit of the company. It's for our own ego. So it's also not a reason. Perhaps you know about the lead time, which is one of the golden DevOps metrics. So basically, this is a project. Yes, sorry, it's a waterfall. I'm old, but you can implement it with different sprints if it suits your fancy. So here at the beginning, you have the specification. I'm sorry, the specification, you cannot do anything about it. It's about the business writing their stuff, or the business analyst, or whatever. So you cannot help them. However, you can be faster in implementation and deployment. So implementation plus deployment is the lead time. This is actually what we want to have. We want to have the shortest lead time possible. And that's one of the reasons why we are doing microservices, because independent deployment, blah, blah, blah. But you know what? This is not a new concern. Back in the days, we had the same issue. Yes, faster deployment is not a new problem. It's an old problem. How did we do it in the old days? Who know about release trains? No, keep your no, I want to see how much gray hair. Oh, you don't have gray hair, you know about that stuff. I'm amazed. So basically, in the old days, we had release trains. So basically, we had planned deployment, every quarter. And then we had to make it to take the train. So there was a deadline. If at that point in time your code was not ready, you missed the train. You had to wait 3 months, next quarter, to get your code in. Was the business happy about it? Of course not, because the release feature was 3 months late, at least. But there was a corner case, there was a huge bug in production. In that case, you could bypass the train. You could deploy whatever. So what happened? Well, we shipped the buggy feature anyway, and then we could fix it. That's how organization works. They put rules, and you find a way to work around the rules. Sorry?
Sounds like games.
Yeah, it's a game, depending on which side you own. So this is how it worked, and yeah, it was really, really stupid. But still, if you have stupid rules, you have stupid workarounds. So one of the problems of monolith is you cannot test everything and release at the same time. So because it takes a long time to test everything, then of course you cannot release frequently. And the solution of microservices is you only release one microservice and you hope that it doesn't break the whole stuff. But that implicitly it says, oh, we only need to test our microservice and it won't break anything else, which in my opinion is a bit like praying for the rain. But anyway, this is how it is. So let's go back to the real issue. The real issue is that if you happen to work on an app for some time, you will notice that some parts of the code change regularly or arbitrarily, and some parts are very stable and never change at all. And that's the problem of the monolith, is we are doing deployment for everything because some parts may change more regularly, again, or randomly. There are reasons for that. Like, if your business is impacted by law, then the law may change arbitrarily. And you have no way of knowing when and where or whatever. But you need to respect the deadline anyway. Business requirements. Hey, you have a formula, and you need to change the formula regularly. Guess what? Again, it's not a new problem. We had before the rules engine. Who has ever used a rules engine? Presto, this is it. You deploy the rules engine once, and then the business can do their stuff. And they can change the business rule however they want. There is no release. They are completely independent. And of course, they take responsibility for their stuff, which they don't like in general because, well, they break production every now and then. So I'm not saying that rules engine are a perfect solution. On the opposite, I never did any development, but once I had a colleague who was an architect of an application where the customer wanted a rule engine because they wanted to be independent of IT in case of changes. And I asked, hey, can I look at how it works? And he showed me the rule. So first, you needed to be a developer. I don't believe any business owner could have changed the rule by themselves. Well, without breaking whatever. And then you needed to understand the business quite well. So in the end, it was still a bottleneck, but it was an invisible one. It was an organizational bottleneck, like the business had to call the developer and say, hey, I want to do this change. Then they would discuss for hours and say, are you sure? Okay, but done. So no more release trains, but still a bottleneck. So the only idea of this microservice, rules engine, whatever, is we have changing parts in the application, and we want to isolate it. That's the only idea. And you have microservices that solve the problem. You have rules engine that solve the problem. You have serverless function that solve the problem. You have other stuff that I didn't know, or I don't know, or I didn't think of. But all of them are focused on this isolating this quick changing part. And perhaps if you are into microservices, you know about the strangling the monolith pattern by Chris Richardson, where he describes, hey, you start with a monolith, And you want to migrate to a microservice architecture. So you just isolate service one by one. And because the book is about microservices, that's its target architecture. Whereas I say that if it's good enough, this is my target architecture. You keep your monolith, you just isolate the parts that are quick changing, or again, randomly changing, and you make them in a different service, or in a different function, or whatever. So here, this is a web app, imagine. You have an API gateway in front. You just need to have this request. Unless of bringing it to the monolith, you direct it to the chopped service. And you are done. And for example, I worked in e-commerce. And e-commerce is a very interesting field. Business always want to promote some products. And the thing is, whatever rule, whatever generic rule you want to implement, business will find a way to have another rule that you need to implement. So even the best promotion rules of e-commerce shops, they are not enough. There are so many reasons they want to change. And of course, afterwards, it's, there is the reason for the promotion, but also on what to apply the promotion. It could be, hey, we do discounts on the delivery fees, or we have 2 products, 1 for free, or whatever. It's really crazy. In general, however, the fastest way is we want to sell more by lowering the price. So the pricing should be very, very flexible. That's the quick changing part. Delivery is pretty stable. Perhaps you want to implement a new delivery provider. Well, it happens once in a blue moon. But pricing is very, very flexible. So the idea is, let's chop the pricing engine. So I have a demo. Let's see how it works. I have pretty unstable internet, so I hope it will work. I have an application. Let's see the code first. This is a Kotlin Spring Boot application. I love Kotlin. So sorry, this is a Java conference, but I love Kotlin. And this is a Spring Boot application. Basically, I have a couple of routes. So I'm pretty modular. So I have the catalog that handles reading the database and getting the products on the home page. I have the pricing. I have the home page that will fetch the catalog and display them. And I have the checkouts, I have the cart, regular e-commerce stuff. I will start my Docker Compose, and I will describe it. As I mentioned, I have this application. Then I have an API gateway called Apache API 6. This is an Apache project. It relies on etcd. etcd is a key-value distributed data store, so it is where it stores its configuration. And then I have this application called ChopShop. And then I have the SQL database, so nothing fancy. I need to create the routes first. So I will direct everything that goes through the API gateway. I will direct it to the application. And now, let's see if it's good enough. So far, the gods of the demo are with me. So this is my e-commerce shop. I can add stuff to the cart. Then I can go on the cart. And here, in one single query, I get the cart, I do the pricing, it returns everything in one go. This is a monolith, right? This is how it works. Perfect. So now, the thing that I want to do is I want to chop that part. I need to make the pricing a route. So I need to isolate the pricing, not only in the code, but on the web. I go to Git because I'm super lazy. And now I've made pricing a route. So I keep my original codes, but now I have a dedicated route with a dedicated handler. Are you following? Yes. And now the fun part is how to update it. I am super bad at that, so I will say docker compose start, and it's called shop, and I hope that at this point it will deploy version 1.3 or not. It didn't. Let's see. It's still one version.2. It's up, sorry. Yes. I'm not a Docker Compose expert, and every time I forget how to update one single component out of all of them. So normally, here, thanks the JVM for starting a bit, like, faster please. Anybody knows a good joke meanwhile? Yes. Okay, 20 seconds, it's good enough. So let's go on here. Now I have version 1.3. So this is the new version. I can still add stuff to my cart. And now I have a caching issue, so I need to reload everything. And now you can see, well, if you are very close to the, I have two requests. First, I do a request to get the content of the cart, then I do a request with the content of the cart to get the pricing. I have two routes. The next step, now that everything is isolated, like is as a dedicated route, the next step is quite easy. What I can do is I go to my next step, and what I'm doing is, instead of like forwarding everything to the shop, I will direct the price route to whatever. Here I choose an Azure function. So I will deploy it, run this. And now the fun part is, without deploying anything, so I keep my monolith as it is. If I redo the shopping, and I go, sorry, here, and I refresh explicitly, then of course, you don't know about it, but you can see that it was super slow. There is a little turtle, because now this route is going to Azure portal. And I cannot get the logs. Like, this is the same stuff that I did before, and now it's JavaScript instead of Kotlin. The logs are very, very slow to get, so you can see the logs from this morning where I tried that everything was okay. And it's still a bit hard to get. But they have been successfully used. So now, without deploying a new version of the monolith, I'm still able to change the pricing on the fly using serverless. This is not a talk about serverless. This is a talk about perhaps you shouldn't do microservices. I hope I prove you that it's possible to do that. Again, my assumption is that you know your application. After some time, you realize which code parts are changing fast, which code parts are stable. Meaning that if you start with microservices, you will never know it. Meaning that you will be making your life complicated for nothing. Because perhaps only a small part of the application needs to change like very quickly and very frequently. Perhaps 2 parts, but probably not the whole stuff. And I believe that's all. So you can read me my blog. My Twitter account has been canceled because I was like fighting disinformation regarding the Ukrainian-Russian war, or the Russian aggression. So that's why today I'm Vyshivanka. This is the Ukrainian traditional shirt. So if you are happy, you can follow me. If you are interested about the repo, everything is on GitHub. So you can check by yourself. You can do it at home. And if you are interested about the written form, then I've written the same talk that I did today, like on my blog. And now we have some time for questions. And I'm happy the internet worked.